All right, today we're going to dive into something really fun, some absolutely genius puzzles from the Indian Math Olympiad. Now, these aren't about grinding through heavy calculations, nope. They're all about finding those clever, elegant shortcuts. They're designed to make you think, and honestly, they're a blast. Okay, let's jump right in with a warm-up. Take a look at this pattern of dots. The first figure has one dot. The second one adds three more. The third one adds five. You can see what's happening, right? We just keep adding the next odd number. So the big question is, how many total dots are there in the 100th diagram? Go ahead and pause here, give it a think. So, how'd you do? The thing about puzzles like that one is that they're not really about adding up 100 different numbers. That would take forever. They're about the first major tool in our mathematical toolkit today, the art of seeing patterns. You know, once you spot that hidden rule, a problem that seems super hard can become incredibly simple. Let's break this pattern down. The first diagram has one dot. Well, that's just one squared. The second has a total of four dots. Hey, that's two squared. The third has nine dots, which is, you guessed it, three squared. Are you seeing it? The total number of dots in any diagram, n, is just n squared. How cool is that? And just like that, we don't have to add anything at all. The answer for the 100th diagram is simply 100 squared, which is 10,000. It's just a perfect example of how spotting the pattern can save you a ridiculous amount of work. It's a beautiful, elegant shortcut. Let's try another one. Check out this sequence. 1, 2, 11, 22, 11, 11, 222, and it just keeps going. Now, the question is, what is the sum of the digits way, way out there in the 999th term? Again, this looks kind of scary at first, but trust me, there's a simple little pattern hiding in plain sight. The pattern here is actually so simple. It all just depends on whether the term's position in the sequence is odd or even. See? The odd-numbered terms, the first, the third, the fifth, they're all made of ones. And the even-numbered terms are all made of twos. And the number of digits just gets bigger by one every two terms. So let's think about the 999th term. Well, 999 is an odd number, so we know it has to be a bunch of ones. But how many? Well, the first and second terms have one digit, the third and fourth have two digits. Following that logic, the 999th term is going to have 500 digits. And if it's 500 digits and every single one of them is a 1, the sum is just 500. See? No crazy formulas, just spotting the rule. Okay, our next tool isn't about numbers and patterns. It's about something else entirely. It's about pure, step-by-step, logical deduction. You have to think like a detective, finding one clue at a time until the whole solution just snaps into place. So here is a classic puzzle type. It's called a cryptorhythm. Each letter you see stands for a different digit, from 0 to 9, and our job is to crack the code and figure out which letter is which number. The puzzle is 1 plus 2 equals 4. Now, I know what you're thinking when you look at this. It seems impossible, right? There are so many unknowns. It's like, where do you even begin? But, like any good mystery, you just need to find that first little thread to pull on. So where do you think that first clue is hiding? Okay, the first and most important clue is right there in the letter F. Just think about it for a second. We're adding two three-digit numbers. What's the absolute biggest sum you could possibly get? Like 999 plus 999? That's 1,998. No matter what you do, the sum can never reach 2,000. So that means the first digit of our four-digit answer, F, absolutely has to be 1. That's our way in. Awesome. Now that we know for sure that F is 1, let's look at the hundreds column. We've got O plus T plus, maybe a carryover from the tens column, and that all equals FO. But since we know F is 1, the sum has to be 10-something, specifically 10 plus O. And here is where the real magic happens. Look at that equation. You see there's an O on both sides? Well, they just cancel each other out. Boof! So we're left with T plus whatever was carried over equals 10. Now think, how much can you carry over from adding two digits? At most, it's 1. So if T plus 1 equals 10, T has to be 9. And just like that, with two little logical steps, we've cracked 2 of the letters. For our third and final tool, we need to completely shift gears. This one is all about thinking visually and, more importantly, systematically. Sometimes the best way to solve a math problem isn't with numbers at all, but by being really clever about how you organize what you're seeing. Take this classic puzzle. I bet you've seen one like this before. How many triangles can you find in this figure?
It's easy to spot a few, right? But the real challenge, the trick, is counting all of them without losing your mind or counting the same one twice. Go on, give it a quick try.
Okay, the secret here is not to just start pointing and counting randomly. That's a trap. The key is to be systematic. So let's start with the smallest possible triangles, the ones made of just a single little piece. If you look, you can see there are 6 of them.
Great! Now for the next size up, let's look for triangles that are made by combining 2 of those little pieces. We can find 3 of these, right? There are 2 on the top row pointing up, and that one in the middle pointing down. So that's 3.
Now we move on to triangles made from 3 pieces. This is usually where people start to get lost, but if you look carefully, you'll find there are 6 of them. You've got 3 sort of wide ones and 3 tall ones that overlap each other.
And finally, of course, you can't forget the big one, the single large triangle that's made up of all the pieces. That's our last one. So you see what's happening? This puzzle isn't really a test of how good your eyes are. It's a test of how organized you are. By breaking the problem down into categories, counting the one-piece triangles, then the two-piece triangles, and so on, we can be totally confident we haven't missed any. And now all we have to do is add up our organized little piles. We have 6 small ones, 3 medium ones, 6 of the larger ones, and 1 giant one, giving us a grand total of 16 triangles. See? No tricks, just a good system. You know, what all these different puzzles really show is that mathematics is so much more than just memorizing formulas or doing long division. At its very heart, it's this incredible, creative toolkit for looking at the world, for finding hidden structures, and for solving problems in these really clever, satisfying ways. So, what's in our mathematical toolkit now? We've got the ability to spot those hidden patterns. We've got the detective skills to use step-by-step logic. And we have that amazing organizational skill of thinking visually and breaking a big, messy problem down into small, manageable pieces. So I'll leave you with one final challenge from the source material to try on your own. In a place called Phoebe Land, they only have symbols for the numbers 1, 4, and 5. So to write the number 6, they combine the symbol for 5 and the symbol for 1. Following that kind of logic, what number do you think this combination of symbols represents? It's another great puzzle that shows math really is a journey of discovery. Thanks for watching.